Welcome to aminacademy.com in electrical engineering regarding capacitor in series and parallel. Let us do some solving problem that is in combination of capacitor in series and parallel. Here, first question. Two capacitors of capacitance C1 6 microfarad and C2 is 3 microfarad are connected in series across a cell of EMF 18 volts. Calculate the equivalent capacitance, the potential difference across each capacitor, the charge on each capacitor. Here, capacitors are connected in series, so the combination of this capacitor is CT 1 over CT 1 over CT equal to 1 over C1 plus 1 over C2 equal 1 over 6 plus 1 over 3 equal 6 is an LCM 1 plus 2, that is 3 over 6. Therefore 1 over CT is 3 over 6, therefore CT equal 6 over 3 is 2 microfarad. We got first the equivalent capacitors. The potential difference across each capacitors. Here, potential difference in series, through each capacitors, voltage is different. That means here voltage is distributed. So, Q equal to C equivalent into V. Now, substituting the values, Q equal to 2 microfarad into voltage is common voltage is 18 volt, that is Q equal to 36 microcoulomb. Now V1 voltage through first capacitor equal Q over C1. Q equal to 36 microcoulomb. Therefore Q equal to Q over 36 here, 36 we got it microcoulomb, 36 over C1 is 6 microcoulomb. What microfarad? 36 over 6 is 6 volt. Then V2 equal to Q over C2. Q is 36 microcoulomb and C2 is 3 microcoulomb. Therefore, micro on microfarad, 36 over 3 is 12 volt. Suppose this voltage is distributed, first capacitor and second capacitor as 6 and 12. If you add up both, that is 6 plus 12 is 18 volt, that is 18 volt is total voltage is 18 volt is there. Next, third question. When capacitors are connected in series, the magnitude of charge Q on each capacitor is the same. That means when capacitors are connected in series, magnitude of charge Q on each capacitor is same. That means charge is not distributed everywhere, it's same. The charge on each capacitor will equal to the charge supplied by the battery. Thus, each capacitor will have a charge of 36 microcoulomb. Here, that C equal to 36 microcoulomb in everywhere. That is, each capacitor it have 36 microcoulomb. Next question. Find the equivalent capacitance between the point A and B. The capacitance of each capacitor is 2. Here, throughout there are 6 capacitors are there, but they are connected in series and parallel together. The terminal point is A and B. Look, this we have to rearrange this arrangement. Like, look at here. First, look at this one. In the system given, 1 and 3 are in parallel. 1 and 3 is parallel. Suppose this connection is come here. That is 1 and 3 is parallel. That is 1 and 3 are parallel and 5 is connected between A and B. Then 5 is connected between A and B. So they can also be represented as follows. Look at your first case. As 1 and 3 are parallel, their different effective resistance is 4 microfarad. So 1 plus 3 is 4 microfarad, that first case. Second one, that 4 microfarad, this 4 microfarad and 2 microfarad are in series. Look at the first thing is this C1 and C3 are parallel, that we have to get it as 1 plus 3 is 4, and C2 is connected with this 4 as series. So we have to get it this as series, that is 4 and 2 is series connection. So it is we have to get it the effective farad, that is 4 by 3 microfarad between these two things, and which is parallel to this 2 microfarad. So this is addition of 4 by 3 plus 2, that is 10 by 3 microfarad comes here. This become together 10 by 3 microfarad, that is series with this 2 microfarad. So here then together 10 by 3 is series with 2, then take the equivalent is 10 by 3 plus 2 is 5 by 4. We'll check first, or at least one will check. 10 by 3 plus 2 is equal 3, 10 plus 6, 16 by 3, but effective is 3 by 10 by 3 plus 2 is 10 by 3 plus 2 is 16 by 3, that is equivalent is here not here 10 by 3, it is 110 here because it is in this 1 over 10 by 3 plus 1 over 2, which is equal 3 by 10 plus 2 equal 10 is an LCM 3 plus 20, 23 by 10. Now these are in series, that is 10 over 3 plus 2, that is in series combination gives 5 over 4. Then that 5 over 4 is parallel to 2, that is 5 over 4 plus 2. Just adding 5 over 4 plus 2 is an LCM is 4, 5 plus 8 is 13 over 4, then reciprocal is 4 over 13 microfarad. That means the total combination equivalent farad is 4 over 13 microfarad. Look at one more time this one. First, this is the first arrange like this one. Look at this. This is a combination capacitor connected together with terminal A and B. Here C1 and C3 is parallel. that is 1 and 3 is parallel, and their effective capacitance is 4 over 5. That is, look at here, these two things parallel, so that is added here, and which is series with 2, then added together this 4 over 3 and this 2 over 4 is with parallel, this added together gives this one, and that is series with 2 farad, and that is 5 over 4, then 5 over 4 is parallel to 5 over 4 is parallel to 2, then gives 13 over 4 effective capacitance. Now, next question. Find the equivalent capacitance between P and Q for the configuration shown in figure. Look at here. This is a capacitors or connected in series and parallel. Look at here, these first two things is parallel, that is 1 microfarad and 3 microfarad, adding is 1 plus 3 is 4 microfarad. That 4 microfarad is series with 4, that is 4 plus 4, 4 and 4. And look at here, this one is this parallel, 6 microfarad and 2 microfarad is parallel. So that is addition of two things is 8 microfarad. That 8 microfarad is series with another 8 microfarad. Now look at here, these two things are series. So 1 by 4 plus 1 by 4 is 2 by 4, that is 4 by 2 is 2 microfarad. And this effective capacitors between these two series, that is 4 and 4, that is 2 microfarad. Here also 8 and 8. 8 and 8 is 2 by 8 is reciprocal is 8 by 2, that is 4 microfarad. Now this 2 microfarad and 4 microfarad is in parallel between the connection P and Q. Therefore add up them, that is 2 micro plus 4 micro is 6 microfarad. The effective capacitance is 6 microfarad in this combination. We have done. Please subscribe our YouTube channel.